Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the brevet exams in 2007, second session, first exercise. So the title of this exercise is Magnifying an Object Using Converging Lens. Two students of grade 9 wish to show their classmates the details of a small object AB. They use a converging lens L and a screen E. Okay, part 1 of this question. One of these two students placed the object AB in front of L as in figure 1. Okay, so they mentioned the figure, so now I can use the figure. Here in the figure, we have the optical axis and the object AB as well as the lens L, its optical center O, and the foci F and F prime. Okay, yeah. So number 1, in part 1 they are telling me redraw in real scale the figure 1 on the graph paper. Okay, so here the direction of propagation of light is not indicated. As a default we take it from left to right. Then the first step is drawing the optical axis at the center, having the same direction of that of propagation of light. Okay, so this is x prime and this is x. Then we place the lens L perpendicular to the optical axis at the center. Using the correct symbol. This is the optical center O. Now the object focus F is located 1, 2, 3 divisions behind the lens. So we have one in front of the lens, sorry. So 1, 2, 3, this is the object focus F. And the point A is located 1, 2 divisions in front of the lens. Above the point A we have the point B located 1 division. A hat is found on B. Let's trace the object. Moreover, the point F prime is located 1, 2, 3 divisions in front of the lens. Now they didn't specify whether F is the object focus and F prime is the image focus or vice versa, but notice that the direction of propagation of light is from left to right. So, and the lens that I'm using is a converging lens, then the object focus will be on the left and the image focus will be on the right. Okay, so this is it for part 1. Let me also write the scale. So along the x-axis we have 1 centimeter and along the y-axis we have 1 centimeter. Now in number 2, they are telling me trace the path of a luminous ray issued from B and parallel to the optical axis of L. So this is an incident ray issued from B parallel to the optical axis. We know that always an incident ray parallel to the optical axis is related to the image focus. Therefore it emerges as if coming from the image focus. And we don't forget arrows on light rays that indicate the direction of propagation of light, which is in this case from left to right. Then part A is done on the figure. Now as for part B, they are telling me trace the path of another luminous ray issued from B and passing through the optical center. We know that this ray emerges without deviation because it's passing through the optical center. And we don't forget arrows on light rays, incident rays as well as emergent rays. So part B done. Then now we have reached part C. Draw then the image A prime B prime of AB. Okay, notice that in part A they told me trace, so no need to justify, and in part B they also told me trace, no need to justify. Now in part C they are telling me draw also means a trace, no need to justify. Now we need to draw the image A prime B prime of AB. So in order to obtain the image, we require for the emergent rays to intersect, but notice that these two emergent rays, they don't intersect behind the lens, therefore we need to prolongate them backward. This is the prolongation of the first emergent ray, and this is the prolongation of the second emergent ray. Because these prolongations are coming from these emergent rays that are coming from these incident rays that are coming from B, therefore their point of intersection will be B prime. Moreover, a hat is found on B directed away from the optical axis, therefore we must place a hat on B prime directed away from the optical axis. So let's place the hat. Moreover, the point A here represents the foot perpendicular of B on the optical axis. Therefore, A prime will represent the foot perpendicular of B prime on the optical axis as well. Okay, now let's trace the image. So this is it for part C. Now part D. Give the nature and the size of A prime B prime. Let's start by the nature of the image A prime B prime. Okay, we can say that since, notice that here, the object AB and the image A prime B prime, both of them are on the same side of the lens, which is in front of the lens. And we know that whenever the image and the object are on the same side, then the image is virtual. Okay, let's say, since the object AB and the image A prime B prime are on the same side, then the image A prime B prime is virtual. We could give another reason why the image is virtual. Notice that here AB is pointing upward and A prime B prime is also pointing upward. So both of them, AB and A prime B prime, are in the same direction, which means that the image is erect with respect to the object, and we know that a virtual image is erect with respect to the object. So we can say also that since the object, let's say since it is erect with respect to the object AB, then the image A prime B prime is virtual. So no need to write both answers, either one is accepted. Okay, now they are telling me the same part, the size of A prime B prime. Let me make some space. Okay, size of the image A prime B prime now A prime B prime consists of 1, 2, 3, 3 divisions, and we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis, and this will give me 3. Now since the scale is in centimeter, then the value of A prime B prime will be in centimeter. Always, all quantities in physics must have unit. And finally, we put our final answer in a box to make the task easier for the corrector to notice our correct answer. So this is it for part D. Now let's move to the next part of this exercise. Now the other students places The other student places AB as in figure 2. They mentioned figure 2, then now I can use it. It's image A double prime B double prime is thus formed on the screen A. The image is collected on the screen. Okay. Here in figure 2 we have the lens L perpendicular to the optical axis. The object AB is located in front of the lens. The foci are still the same. And we have the screen E located behind the lens. Okay, let me make some space. And let me write here that the nature of this part was virtual. Probably that I will use it later. Okay. Now in number 1, they are telling me redraw in a real scale figure 2 on the graph paper. The direction of propagation of light is still the same, so this is part 2. From left to right. And the optical axis has the same direction of that of propagation of light from left to right. Okay. So this is the optical axis x prime x. Then we place the lens L perpendicular to the optical axis at the center. Let's label some stuff. This is the lens L. This is the optical center O. The object focus is located 3 divisions in front of the lens, and the image focus is located 3 divisions behind the lens. The point A is located 1, 2, 3, 4 divisions in front of the lens. And the point B is located 1 division above A. A hat is found on B. Now let's trace the object. Moreover, a screen E is located behind the lens. Now let's count the number of divisions between L and E. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the screen E. Must be located here and perpendicular also to the optical axis. The scale is the same, 1 centimeter along the x-axis and 1 centimeter along the y-axis, and this is known as a real scale. Okay, I hope we didn't forget anything. Now number 2, trace the path of a luminous ray issued from B and passing through the object focus F. Okay, they are telling me trace, so no need to justify. This is an incident ray issued from B and passing through the object focus. We know that always incident ray passing through the object focus is related to the emergent parallel ray. Therefore, this ray will emerge parallel to the optical axis. Okay, and no need to justify. And we don't forget arrows on light rays that indicate the direction of propagation of light. So part 2 is done. Now part 3. Specify on the redrawn figure with the justification the position of the image B double prime. Okay. So here they are telling me that the image is formed on the screen. And whenever the image is formed on the screen, in order to determine the image, one ray is sufficient. Why? Because this ray issued from B, we know that it emerges from the lens going to B double prime. Then the intersection of this emergent ray with the screen will be B double prime. Moreover, a hat is found on B, so let's place a hat on B double prime. The hat here is directed away from the optical axis like this. Then the hat here will be directed away from the optical axis. This is the hat. Now They told me here in number 3 with the justification. So we did the tracing, now let's justify. Then the image B double prime is the intersection of the emergent ray with the screen because the image is collected on the screen. Now part 4, they are telling me draw the image A double prime B double prime. So we already traced B double prime, it's left to trace A double prime. Notice that here A represents the foot perpendicular of B on the optical axis. Therefore A double prime will also represent the foot perpendicular of B double prime on the optical axis. Now let's trace the image. This is the image A double prime or B double prime A double prime. So for done, now let's move to part 5. They are telling me give the nature and the size of A double prime B double prime. Okay, nature, or let me make some space. Number 5, nature of the image Okay, since the image is collected on the screen, and we know that only real image can be collected on the screen, then we can say that then the image A double prime B double prime is real. We can also give another justification for this equation. We can say that notice that the object AB is in front of the lens, whereas the image A double prime B double prime is behind the lens. So the object and the image are on opposite sides of the lens, which means that the image is real. Okay, since the object AB and the image A double prime B double prime are on opposite sides, then the image A double prime B double prime is real. Moreover, we can say that since the image AB is pointing upward and A double prime B double prime is pointing downward, then A double prime B double prime is in opposite direction with respect to AB, which means it's also real. No need to write both answers, either of them are accepted. Now in the same question they are telling me the size of A double prime or B double prime. Then let's say size of the image A double prime B double prime Now A double prime B double prime consists of 1, 2, 3, 3 divisions, and we multiply by the scale along which we have counted the number of divisions, which is scale along the y-axis, and this will give me 3 centimeter. Therefore A double prime B double prime is equal to 3 centimeter. Now finally part 3, the conclusion. Which of the two students was able to show the details of AB to all his classmates at the same time, and why? Okay. So here, for two different positions of the object with respect to the lens, we obtained two images, one which is virtual in part 1, and the second one which is real and collected on the screen. And we know that whenever the image is collected on the screen, it can be seen for several individuals at the same time. Therefore, students of this group of part 2 will be able to show the details of the small object AB to all his classmates, the student. Okay, now let's say that since a real image is visible on a screen for several individuals at the same time, then the other student, let's say, was able to show the details of AB to all his classmates at the same time. And by this I have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.